Welcome to the Containers as a Service theater session at TechNet Cyber. I am Josh Rinke, Program Manager with Mantech, and we are a proud supporting partner of TechNet Cyber. I'm happy to introduce our next session on behalf of AFCEA International. Shauna Martin, Virtualization Branch Chief of DISA's Hosting and Compute Center. Ms. Martin is responsible for providing strategic direction, guidance, and mission oversight for enterprise virtualization support teams responsible for virtual hosting and compute infrastructure environments, containers as a service, Stratus, and virtual desktop infrastructure. These critical hosting environments are comprised of over 500 hosts, 8,000 virtual machines, and hundreds of critical applications. Prior to this role, Ms. Martin established and managed the Defense Enterprise Email Service Desk, which supported over 1 million end users. Ms. Martin began her career with DISA in 1997 as a contractor, transitioned to civilian in 2009. And I'll turn it over to you.
Hello, everyone. Thank you, Josh, for the introduction. I'm Shauna Martin. We've got with us today our technical SMEs, Dwayne Page and Kevin O'Donnell. We're excited to be here this afternoon. We'll be sharing details on the Containers as a Service offering, as well as demonstrating a few of our capabilities with a few 3 to 4 minute videos. So I'd like to begin explaining a bit about container technology in general. So containers include the application and its dependencies packaged into code, which can run in any environment. Think of it like virtualization at the OS level. This abstraction from the OS allows the applications to share a single OS kernel, making them lightweight and portable. So a bit about the offering itself. Containers as a Service is a Kubernetes container hosting capability. The platform runs at the data center in DISA, Oklahoma City, and utilizes Red Hat OpenShift. Now, containerized applications hosted on that platform have a significantly reduced compute requirement and a subsequently reduced cost versus what we see with virtual machines. Now, since containers do not have their own operating system, there's no longer any OS patching or OS licensing to worry about. That means less application downtime for the application, better security, and no configuration drift. The platform is designed to facilitate rapid application development, and because containerized applications are lightweight, they allow for standardization between your development, prod, and production systems. Lastly, containerized images are started, stopped, and deployed in a matter of moments. It's almost as fast as you can click a mouse. That leads us into our first video demonstration. We're going to show the speed of deploying a web server, then we'll make a change to that code and redeploy.
OpenShift console, deploying the web server's code, some of the horizontal scale.
Can you hear the audio?
Here I'm in the OpenShift console with DISA engineering namespace. I'll be utilizing a simple Hello World Nginx web server engine from the key. Hi, my name is Jeremy and I'm part of the CaaS team. Today I will demonstrate a web server deployment within the OpenShift console, deploying the web server's code, some of our horizontal scaling capabilities. Here I am in the OpenShift console and the DISA engineering namespace. I'll be utilizing a simple Hello World Nginx web server engine from the key.io repository. We will do this by clicking on Create Deployment. And in the form view, we will name our deployment Hello World. Leaving the default settings with the exception of the image name.
Can you turn that up?
What's up?
We'll point to the Hello World Nginx image within key.io and click Create.
Okay, I think it's the same.
The next step is to allow end users to access our new web server. We would do this via the service and route resource within OpenShift. First, let's create the service. I've input my YAML for this service. We've named it Hello World in the namespace DISA Engineering. It will listen on port 80, the service will, and the target port is 8080, which is the port that the containers will be listening on inside of the pods. We also have a selector of app Hello World. All pods with this label will be routed traffic load balanced through the service. Let's click create. Now that we have our service, we need to expose that service. To do that, we create a route. We'll name our route Hello World. And we'll choose the service we just created. We'll secure our route with edge termination. Now that our route's created, let's check our link. In just a few minutes of time, we have now deployed a web server within OpenShift. Let's now fast forward 1 week. Your developers have been working hard, and now the code for the deployment for this web server is in your Git repository. Let's check that out. So here we have the code for the Hello World deployment. To deploy this code into the namespace, we will use Argo CD. Argo CD is responsible for continuously monitoring all running applications and comparing their live state in OpenShift to the desired state within your Git repository. Here we can see that we are now out of sync now that the new code has been pushed to the Git repo. To deploy this code, we will click sync. You can see on the right side that the new pod for the new code is being created. The new pod is now in a running status, and it terminates the old pod. Our sync status is now synced, and we are now healthy. Let's refresh our web page. Congratulations, you've now deployed a web server's code.
So that was on NIPRNet when he did that. That's how fast that deployment went. That's how fast that Nginx came up. And that's how fast it was online. So you didn't see any IPs there. You didn't see massive configurations. You didn't see a bunch of guys on keyboards for hours. That was online. You can see the URL on the top. So that's how quick it is.
Sorry for the back and forth. We had some technical problems with our slides, so had to get a little creative. It's good. So why CaaS? CaaS can handle impact levels up to IL5. It is on-prem in the DISA Oklahoma City data center. It's fully ATO'd, and it's integrated with Global Directory. The hosting platform is truly a hybrid cloud technology. It can reach out to the commercial cloud offerings, or it can reach back to a bare metal database hosted within our data centers. There's no hidden ingress or egress fees with CaaS, and because it resides on NIPR, there's no reason to funnel your traffic through a meet-me point or a CAP. It allows our mission partners to focus on their application and their mission. DISA manages the complex underlying Kubernetes and orchestration layer, and mission partners can focus on what matters most to them, the development of their application. Mission partners can develop their application directly on OpenShift with the OpenShift's onboard development tools, or they can run a Tekton pipeline inside their namespace. You can do any combination of development, test, and production within various namespaces on the platform, or you can develop out in the commercial cloud via JWCC or with DISA's Vulkan capability, and then run your production application on CaaS, which keeps your data behind the security of the DISA comm stack. You can go ahead to the next page. So our next video demonstration, we're going to illustrate manual auto scaling and then, manual scaling and then some auto scaling that can be done within the platform based on your CPU utilization consumption.
A great feature in OpenShift is scaling. We could do this manually or automatically based on resource consumption. Returning to our Hello World deployment, I will now demonstrate a manual scaling and scale from 1 to 2 pods. On the left side of my page is the deployment, where I can manually scale. On the right side are the pods within that deployment. Once I scale, we should see a new pod creating and progress to a running status. We have now manually scaled from 1 to 2 pods. These pods are behind the service that we created earlier for our route, and they are load balanced behind that service. So if we go to our web page and refresh, we now have our web page load balanced behind 2 pods within that service. We can also automate the scaling with the horizontal pod autoscaler. We can set this to scale based on the amount of CPU consumed. I will now create the HPA for this deployment. I have created an HPA for the Hello World deployment. The minimum replica will be at 1 and the max will be 7. Your utilization threshold will be 30% of the CPU for this deployment, which is currently set to 20 millicores. Once it exceeds that threshold, the deployment will auto-scale and deploy new pods to accommodate for the load. As you can see, the manual deployment, a manual scaling of the pods is now being managed by the HPA, and we no longer have the ability to manually scale. I will now generate a load across the pods and demonstrate the HPA's ability to auto-scale. Under the Metrics tab of this pod, we will be able to monitor the CPU usage for this pod. As I generate the load, we will see the load rise until it passes the threshold, and on the left side of the page, it will auto-deploy a new pod. We can now see that the deployment is auto-scaling. As we see on the right side, the threshold is being passed. We return to our Pods tab. We can see that our new container was being created and is now in a running status. We have now auto-scaled to 3 pods. 3 pods are now load balanced behind the service initially created. Let's refresh our web page. We have demonstrated the ability to scale manually and automatically within OpenShift. This ability will help accommodate for loads as they happen across your deployment. Thank you for your time.
All right, so we've explained and demonstrated a lot of the DevOps power realized with CaaS. Now we want to review a bit about the security side of it. Again, the platform is built on Red Hat OpenShift, which is fully CNCF compliant Kubernetes distribution and container platform. It is FIPS compliant and CAC enabled. There's a rich marketplace of third-party containers and operators, fully supported by OpenShift. Lastly, it has the added bonus of advanced cluster security powered by StackRox. That includes runtime container scanning. So in our last video, we're going to show just that, StackRox container scanning. We will pull up our vulnerability status on our web server, pull down the latest version of that code, and rescan the server so you can see the changes. Again, notice the speed at which this is happening.
Within OpenShift, we use Red Hat Advanced Security Cluster, which is powered by StackRox. Red Hat ACS provides vulnerability management by scanning your deployments and provides those results into a dashboard. Results can be exported into a CSV format accepted by EMAS. It also provides role-based access to give admins within your program the ability to view the finding details, while also allowing cyber personnel such as an ISSO to manage those findings. Here in this dashboard, you can see within our namespace that we have 6 different deployments. Under the vulnerability management, as an ISSO, you can also perform risk acceptance and approve false positives. You can create recurring reports, which would be emailed to you in the CSV format. Let's investigate our Hello World deployment. Here in the top right corner in the pie chart, you can see that this deployment has 665 CVEs, categorized as critical, important, moderate, and low. You can see that you're using the key.io Hello World latest image. After discussing this with your developers, it seems they should be using the latest version from the Red Hat catalog. To do this, they will edit their deployment code and redeploy. We will edit the image line to point to the latest image that should be used. Now that we've committed our code, let's check Argo. Argo is now showing out of sync. Let's deploy our new updates. Here you can see that our update is deploying. Our new pod is in a creating container status. The old pod is terminating, and the new container is now in a running status. Let's check our web page. All right. Let's go back and check our vulnerability report in our dashboard. Here in the top right corner, you can see we're now at 97 CVEs. This mitigated 568 CVEs. You can see also underneath that we are using the latest image deployed by code. In just a few moments and a few lines, you've now mitigated 568 CVEs. I hope you've enjoyed this brief introduction into Red Hat ACS.
Yes.
Thank you.
In the background also, you see these automated deployments coming in through Argo. There's also integrated logging, backups, monitoring, alerting, and pod restoral if your application breaks. There's health checks that can be built in that'll automatically restart your pod and get you back online.
So that concludes our demonstration today. Now I'd like to open it up. Any questions that anybody may have? We've got the technical SMEs up here, so fire away. All right. Yes, sir.
Not really.
Can you hear me? Good afternoon. My name is Hayden Snyder. Thank you for the presentation. Just curious how CaaS compares to the other DevSecOps platforms like Platform One's Party Bus or the Navy's Black Pearl in terms of providing continuous ATO for applications, and what the process is for negotiation with your own AO for vulnerabilities that may have been remediated or mitigated in code but are still popping into CVE scanners because they're using outdated versions or something of that nature.
Right. So we have not crossed into that area of this capability yet. We have had multiple conversations with Platform One about how they are doing that, and also with our DISA cyber team to kind of lay down the groundwork of what would it look like to take some of the awesome things that they're doing and be able to provide that same kind of offering in our area. Thank you. Anything else? Okay, if anybody has any questions afterwards, please feel free to come up. We'll be up here for a few more minutes. Thank you, everyone.